welcome to another video from Lockdown Electronics with me, Bill. Now you may recall a few weeks ago I did a review on this clamp meter, that's the Kaiweets HT206D, and I also used this meter, the KM601, and I sort of compared and contrasted these and talked then about measuring current. And what I want to do today is go, I guess, right back to basics and really look at how we might measure current. And it's also quite a handy bit of revision from the point of view of Ohm's Law as well. So it's really simple stuff, but hopefully for some of you it's going to be a handy bit of revision. So you might recall in the previous video I produced a meter that I bought nearly 50 years ago. Here's a little bit of footage of the inside of it, and I'm just showing you there the two components which act as current shunts. The bar is the 10 amp current shunt, and the resistor I point at is the 500 milliamp, 5 to 500 milliamp current shunt. So what I want to do today is particularly look at how we can use current shunts for measuring current in a practical sense, and then want to look at a wacky way to make use of a clamp meter. So I quite enjoyed putting this together, and I hope it's useful to you too. Let's get to the bench. Okay, we're going to start with first principles, I guess, if you like, to see what we're trying to do here. So we're going to make use of this hopefully very familiar formula, which is Ohm's Law. Volts equals current times resistance, and if we're looking at measuring current, we clearly need to know the other two things. So we need to know the volts, we need to know the resistance, and if we've got those two, we're able to calculate the current. Now again, this is probably simple stuff to mathematicians, but if maths is a bit scary, just look how simple this is. So what we want to do is rearrange this in terms of I, or current. So to do that, what we're going to do is we're going to divide both sides of this equation by resistance, like that, and that's okay. Here we've now got R both sides of the line, so they cancel out, and that effectively leaves us with V over R equals I. So if we divide voltage by resistance, that should give us the current. So let's look if that really works, and to do that I've got an incredibly simple circuit I'm going to use. So what we've got here is a white LED. I've just picked white because it draws more current than other colours, and I've got a 330 ohm resistor as the current limiting resistor, and I've got a 5 volt supply. If I just ran the LED off 5 volts, it would very quickly, the current would run away and it would destroy the LED fairly quickly. And to prove that works, we can just connect up there, and there we are, working away, no problem. So let's first of all just check that this really is a 330 ohm resistor. So I've got the Kaiweets KM601 here set to resistance, so I'm just going to measure there, and that's saying 327 ohms, which is well within the 5% tolerance of a 330 ohm resistor. So 327 ohms, yeah. So let's just make a note of that. So R is equal to 327 ohms. Right, now let's turn on this supply. Let's change the function of the Kaiweets to DC volts. Okay, and now what we'll do is we'll put the probes onto the resistor again, and now we're measuring the voltage across the 327 ohm resistor, which, let's do that a couple of times, comes out at 2.05. let's just go for 2 decimal places. Comes out at 2.05 volts. So again, we'll make a note of that. So volts equals 2.05, and units are obviously volts. So let's now check what we think the current's going to be. In fact, before we do that, let's do a bit of maths and see what we think that's going to be. Remember we said volts divided by resistance should equal the current. So we've got 2.05 volts divided by 327 ohms, and because this is a scientific calculator, the answer it gives me, just to confuse you, is 6.26 times 10 to the minus 3, and what that really means is that you need to move the decimal points 3 places that way. So if I put 2 decimal places in front of the 6, so it's saying about 6.2 milliamps, if you like, or 0.0062 amps. So about just over 6 milliamps is what Ohm's law says the current should be. Let's see if that's true. So we've got 6 milliamps. So let's now move the lead onto the milliamp setting, and the nice thing about the Kaiweets is it's automatically set itself to milliamps because it knows I've put the probe in there. So I'm going to disconnect that, and I'm now going to put the meter in series with the supply so we can measure the current in the conventional way, like so. LED lights up, 6.25 milliamps, and we're predicting 6.2 milliamps there. So hopefully that's got the general principle. And if you've got a circuit like this with a really simple resistance in series with the component, it's relatively easy to work out what the current is. So how is that normally used for measuring current? Right, I'm going to reset the bench and then we'll have a look at that. Okay, so I've just rearranged the bench, and hopefully this is a slightly more shall we say realistic way of measuring current that you might want to incorporate in your circuit. Earlier on we used the 330 ohm current limiting resistor to check what the current was on in the LED, which gave us a reliable answer, as we saw. We don't always have the convenience of having a known resistance in series with whatever it is we're checking. So the way a multimeter does it is to have some kind of resistance in there. Now I've got this resistor here. It's a high wattage resistor of a very low value, and measured on my LCR meter. Here's a screen grab of the display. You can see the resistance is about 0.0127 ohms. That's the number I'm going to use for calculation purposes. To be unfair of me to try measuring that on either of these, because that is only about that's only slightly more than I would expect the resistance to be in the probe lines. So asking a conventional multimeter to make an accurate measurement of a resistance like that using the 2-wire method is a big ask. And the LCR meter has these Kelvin clips, which have actually which is the 4-wire method of testing, so it's a much more accurate result, understandably. So I've got the resistor in series, and I'm using an automotive bulb again as a load that draws a bit more current, and I've got a voltage of about 9 as the power supply, but actually that doesn't matter for our purposes. So I've got the clamp meter in series, and bear in mind this is in DC mode, and in fact I tell you what I'll do, let's just turn that off. Yeah, let's just zero that. Remember, you might remember from previous video that it's important that in DC mode you do actually zero the clamp meter before you take a reading. So that's saying about 1.5 amps, 1.55 amps. So I'd expect that to be somewhere near, bearing in mind we're in the 60 amp range, and so we're right at the bottom edge of what that's normally expecting to measure. So it's about 1.5 amps, something like that. So I've got the KM601 set to measure volts. So let's measure the voltage across that resistor, and as you can see there we're getting 0.148 volts. So let's just make a note of that. So volts is equal to 0.148, and you remember that what we actually need is V over R should give us I. So we're expecting that to be about 1.5 amps. So if you're really clever, you've already done that in your head. I'm not really clever, so I haven't. So we got 0.148 divided by 0.1027, if I've pressed the buttons correctly, gives me about 1.44. So by calculation, we're within well, 0.05 of an amp on there. So that's clearly a practical way of doing it. In fact, that low value resistor, I bought 5 of them because I wanted one for a project where that was used as a current shunt, and the voltage across it was being measured by an Arduino to enable the Arduino to sense current. And finally, just for completeness, let's just pop the KM601 into the 10 amp range here, and let's put it in to series with all this circuit and see what we get. And the Kaiweets is making it sorry, well, they're both Kaiweets, aren't they, but it's making it 0.145, which is pretty close to our calculated value of 1.44. So considering where the clamp meter is actually working here, it's doing pretty well to give us an answer that accurate. So that's how you measure using a current shunt with a low value resistor. And obviously this resistor here is taking 1.5 amps, and currently I can't even feel it even getting slightly warm. But of course the whole point of having a low value resistor of 0.1 ohms is that it doesn't dissipate very much power. You could use a larger resistor, but you just need to then start doing the other version of Ohm's Law to just check what the watts are being dissipated there. And we could just check that if we wanted to for completeness. So we know that the current is 1.45 amps, so let's multiply that by the resistance. 1.45 times 0.1027 gives us 0.15 watts. So that resistor is dissipating as 0.15 watts. I can't even, it just feels like it's at room temperature, maybe a very slight hint of warmth. But so there we go. That's a more sensible version of a current shunt. Okay, and finally, just to be slightly wacky, let's do something a little bit crazy. So what I've now got is still got this 0.1 ohm resistor in series with the automotive bulb, and we've got a current according to the series method on the KM601 of about 1.4, just over 1.45 amps, which is what we'd expect once the bulb has sort of settled down at its temperature. And the clamp meter is saying 14.8 amps, and the astute of you will now spot it. That's because something odd going on here. So what I've done here is, if you've decided to get a clamp meter and you don't have a multimeter and you want to get perhaps some slightly more accurate lower current measurements, here's a bit of a suggestion. I'm not saying this is precise and accurate, but it is giving me a more accurate result. So what I've got here is I've got 10 turns of a wire just loosely wound around the clamp. I zeroed it beforehand, so what we should now be getting, because we've effectively got 10 turns as the primary instead of 1, remember the meter for measuring purposes would expect 1 turn, i.e. just the wire through the clamp. I've now got 10 turns, so we need to divide the result by 10, by the number of turns, and that should be the current flowing. So if we move the decimal point along 1, that's saying about 1.49 amps, and the series current measurement on the multimeter is saying 1.45 amps, so we're 0.04 amps different, so not terribly much really. So that's actually quite a nice demonstration of the way the clamp meter senses current, using electromagnetism effectively, although for the DC mode it's using a Hall effect sensor instead of a kind of a transformer. but yeah, as long as you've got your 10 turns spaced and not overlapping each other, and this is probably quite a reasonable way to do it. But remember, we're doing DC current here, and 10 turns of a coil on DC current isn't going to have very much effect. That could potentially have an effect if that's measuring an alternating voltage, because obviously the coil has an inductance of some sort, and it also has a reactance, and that could affect measurements of an AC current. But here, as you can see, which that's saying if you divide by 10, 1.49, that's saying 1.5, so I reckon that's pretty close and doing the job rather well. So there's a novel way to make use of your clamp meter. This is the HT206D. This model, the HT206D and the HT208D, both do DC current, and if, as I said in previous video about these two meters, if you've not considered a clamp meter as your meter for your hobby, maybe it is worthwhile because of the ability this has to measure very high current at both DC and AC, and if that's something you need, then you know, maybe it's worth considering. So there you go, a bit of a novel use for a clamp meter in DC mode. Okay, well, a bit of Ohm's Law revision, a bit of practical current measuring. It's simple stuff, but it's something, if you're going to get into electronics, you sort of really do need to have embedded up there, so that so it's just easier to recall, because it's very handy. And there are certainly circuits out there where you'll come across a resistor in series with a power supply, and you can potentially use that for making current measurements if you want to see how much your circuit's drawing, if that's an easy way to do it. And my slightly wacky use of a coil on the clamp of the clamp meter has hopefully been interesting for you as well. If the clamp meter is your only meter, what that does allow you to do, and I maybe didn't make that completely clear when we were looking at it on the bench, because you're dividing the result by 10, you're sort of starting to work a bit nearer to the middle of the range of the meter, rather than right at the extremities. So hopefully that was being shown by the fact that it was giving you a more accurate result. Right, well, thanks for watching. Please hit the like button, even if you didn't, because it really helped me. I suppose you can hit the dislike button if you want to. Be great if you could subscribe, that helps the channel too. Have a look at the links down below, particularly to these instruments. There are links to these, and if you use the code, if you fancy getting one of these, not only does it get you a discount, it also helps the channel, and I'd really appreciate that. See you on the next video.